Shebel has his PhD since 2005. He's working as assistant professor in the Faculty of Foreign Engineering Technology, graduate from France. He specialized in the application of different artificial intelligence techniques with mechatronics engineering systems.
Exactly.
And some language skills are Arabic, English, and French.
Thank you, sir.
عرض الشرع فوق
Okay. Good afternoon, ladies and gentlemen. As Professor introduced, my name is Shebel. I'm an instructor, assistant prof at the Hotel Catalonia University, Faculty of Engineering Technology, Amman, Jordan. I would like to present for you my work summarized by the paper titled Evaluation of Self-Tuned Fuzzy PID Controller over Titration Process. So, before starting with the slides, I want just to explain the main keywords of this paper. The first keyword is self-tuned fuzzy PID. Most of you know about the classical and conventional controllers that used in automation, which is PID, proportional integral derivative combined algorithm, which is classical, which has a mathematical foundation. Now, if we think to develop the mathematical foundation into physical concepts, so we think about fuzzy as an intelligent technique to use with non-model process or with extremely nonlinear processes. Now, the performance of PID would be modified and enhanced using the fuzzy PID. Means the fuzzy is the physical concepts and PID is the mathematical foundation. But fuzzy logic systems have a lot of problems or points of weakness. The main point of weakness for fuzzy as an intelligent technique is that it's a parametric system. In the fuzzy logic controllers, there are a lot of parameters to be pre-adjusted and tuned. Okay, now how to solve this problem? How we could adjust, calibrate, or tune these parameters? Different researchers in the last decades have tried different algorithms and techniques, adaptive and self-tuned algorithms, like genetic algorithm, like neural network, means fuzzy logic supported by neural network, fuzzy logic supported by genetic algorithm or by expert system to modify the performance of the fuzzy logic. Here in this paper, we introduced to modify the performance or the linear performance and the shortage of fuzzy logic controlled by a self-tuned algorithm, means its different equations have been added to the system to modify up to date, okay, the fuzzy parameters, which is K, B, Ki, Kd. And the case study in this paper was an industrial or much more popular industrial processes found in industry, locally in Jordan, in different medicine industry. I take a case in one of the huge and large industrial sectors in Jordan concerning with medicine industry. I entered the labs, I found the titration process, which is a pH reactor, and I take this as a case study to study or to ensure the validity of the designed self-tuned fuzzy PID. First, I introduce for you to be conventional with the pH reactor. pH reactor, we all studied chemistry and we know the pH. Okay, I'm working between, in the scale of the pH is between 0 to 14 or 1 to 14. If the solution in inside the tank is acidic, okay, so it's less than 7, or basic, so it's greater. If it's equal to 7, so I'm talking about a neutral solution, and that's what I'm looking for with titration process. Titration process means if I have a base, which is, as an example, NaOH, enter from the yellow arrow, and I have an acid, as an example, I have H2S, HCl. Okay, so the mix or the solution, the final product should be of pH equal to 7. How to save, or how to follow the target? To follow the target means how to guard the reference between the variation of the pH value with respect to the flow phase of rate of phase, to the flow rate of phase, sorry, QP, or the concentration of phase. Or, from the other side, the other inlet stream, this flow rate of acid and the concentration of acid. That means that mainly I have 4 parameters to be regarded, to be observed, to be put under control, to finally manipulate the main process variable, which is pH. This system physically has 2 inlet streams, 1 outlet stream. I have a stirrer to make the homogeneity or to stable the homogeneity of the solution, and this is an electric motor. In this sector of industry I have visited in Jordan, they have an pH reactor, and there is a pH meter that measures the pH online. Okay, the kit, the tool, the overall trainer or kit expends the company $150,000. Okay, it's come from Italy, and if there is any problem or technical problem with this equipment, they will take it to put it in the stores as a stock. Means we will lose $150,000 because we cannot maintain or develop the system. Okay, my idea was as it. If we can replace the pH meter, the hardware, the real hardware, by a numerical model that I could write with, as an example, any simulation environment, MATLAB or LabVIEW. I used LabVIEW. So I can download this program in real time, because LabVIEW, as all of us know, can match reality. Okay, MATLAB, it's a virtual environment, but with interfacing access, I can match the reality. But LabVIEW, I can talk with reality. I could receive information from analog to digital converters and send commands from through digital to analog DAC and other interfacing stages. So, why not to replace this pH meter by a numerical model? Okay, it's a software solution, and finally, it will cost 1, 3, 4, 500, 700 maximum euro. Okay, it's IC chip, so I can compensate the real hardware with the numerical solution. This is the idea for evaluation pH. Now, the method or the technique used to evaluate or to estimate the pH without measuring as an estimation, it was a neural network. And here, as we listened before from colleagues, I used 2 algorithms of neural network. The first is multi-layer perceptron, and the second is radial basis function. Why 2 of them? Because multi-layer perceptron has a point of weakness and point of strength, and the others, on the other side, RBF the same. So, if can I develop a hybrid system between MLP and RBF to work together, that means finally that the problems in MLP could be overrid by RBF and vice versa. So, we could compensate this hardware accesses with numerical solution. First, this is the physical system. We can see that mathematically, and this is one of the most important challenges that meet engineers and firms in this science. Physically, this is the system, and the mathematical equation that represent the system, as you see here, is of extremely nonlinear, or means a lot of degree of freedoms to be treated. So it's mathematically complicated to be modelized. Now, the idea of AI, or the philosophy of artificial intelligence, is to be
have not a real model system. Means I have to deal with systems as a black box. Considering the physical relation between inputs and outputs without concerning of what real or actually inside the pH reactor or the plant occur. So I will not talk about the variables, the variable, the concentration, and the K, which is acidity factor. The acidity factor for strong acid means if I have a solution with a strong acid, it will be equal to 1, and other value would be if it was weak acid. Mathematically, it's a complicated equation. Physical, as I told you, it's expensive. So we would get a conclusion that say experimental inaccuracy in measurement of pH should be resolved. This is the first challenge to geometry, the problem. The second, as you see, after derivation and reformulation of the three equations, we can get, and this is not the equation you can find in literature, the relation between pH and acid flow rate, acid concentration, QACA, base flow rate, base concentrations, QECD. I'm concerning with acid flow rate, QA. So this relation could give a direct nonlinear relation between pH, this is my process variable, and the manipulated variable to be measured, which is QA. Now I would measure the flow by flow sensors, which is much more cheaper than pH meters, and then the second stage I could estimate the pH value. So I have finally an estimated pH value to be fed back into the controller or through the controller. So the first part of this work is to design the numerical solution in the simulation environment to estimate the pH value by measuring flow rate of base, and this has been justified by hybrid system neural network. As you can see here, we have a graphical representation for the real relation between, on the x-axis, the base flow rate in liter per minute, and all of these values are real values. It has been obtained in the labs of this medicine industrial sector. The output, which is y-axis, is pH. So this value would be measured and pH estimated. The real curve say that for strong acid, when K is equal to 1, it would be like that. And for weak acid, it will be on the dashed line. If we compare the solid curve and the dashed line, the first comment or the first note, we could conclude from this figure that between when the Q base changed from approximately 0.9 liter per minute to 1.1 liter per minute, we have a very fast variation of pH. Means when the Q base less than 0.9, it's increased, pH increased, but slowly. So it's a linear relationship. But between 0.9 and 1.1, it's extremely nonlinear. This very fast variation could lose the control system its stability. And you know, in the control system design, all the interest is to enhance the stability and modify the response of the closed loop systems. So all the time I'm looking as a control engineer for the robust and smooth controller that could incorporate the industrial inquiries and the nonlinearity of such processes, plants like pH reactor. So how can I, first question, how can I obtain the estimated value of pH by measuring of Q base has been resolved by using hybrid neural network, and how to design a robust and smooth controller. The second act of this research activity has been resolved by a self-tuned fuzzy PID. Okay, As I told you before, I used two algorithms of neural network. The first one was multi-layer perceptron, and the second is radial basis function. As we will see later, the main difference between the two, one of them give you the accuracy and the other support you by speed. So, if can I accomplish the features of speed and the features of accuracy, I could finally achieve